Hello, welcome to Learn with PMW. In this session, we are looking at inheritance in Python. This is part 5 of our videos. We go deep in concepts of object-oriented. We are no longer calling it introduction to object-oriented, but the core concept of object-oriented programming. As we indicated earlier on, that we are now looking at inheritance. All right, now before we do some practical works, we have to understand what inheritance is. Yeah, from the common word, we know what inheritance is. Okay, so now inheritance in object-oriented programming or in any programming aspect is where a child class obtain or inherits all the properties and method from a parent class. So it's where a child class actually obtains or inherits properties and methods from a parent class. And we understand in real life situation, we don't obtain everything about our parents. That is my father or my mother. We just contain certain attributes. Now, what's in programming, we actually obtain everything from a parent class. So by saying a parent class and a child class, maybe there may be some confusion. A parent class just means a existing class, an existing class. That's a parent class. Then, then a child class is actually called as a new class. I hope you can see this kind of scenario. So a child class, we are just referring to a new class, and then a parent class is called the existing class. So you may also be found with other terminologies, such as an existing class or a parent class may be termed as a base class. Depending on the situation, it may also be called the super class. Okay. Then for the new class or a child class may be called as a derived class or a subclass. Yeah, that's all. So don't be, when they phrase the question or create a base class or a parent class, don't be confused. Okay, from there, we also want to understand what kind of relationship does inheritance draw. Yeah, so it models there is a relationship. That's what inheritance draw. So it models is a relationship. What does that mean? For example, we may have a class which is an animal, and we may have a lot of animals in this world. That is the names of animal: dog, cat. Sorry to say, a human being is an animal as well. So a dog is a animal, a cat is a animal, a human is a animal. That's why we are saying that inheritance, it draws relationship, which is termed as is a relationship. All right, from there on we proceed. Okay, from that point we are going to proceed to some key concepts in inheritance. Okay, so what should we know before even we start programming? Most of the things that we are going to found that we are doing, you're going to experience this method called the super method or super function. So this super method, it helps us to initialize the constructor in the child class. That is, if a parent class, which is an animal, at the constructor, which is an initialize method, and it has some argument in there. So we want, as well as the dog class, to obtain the constructor of the parent class. So we'll be using this super method in order to call the constructor of a parent class. I think we understand there, and we are going to see this in practical. Other thing that we are going to meet in inheritance, we are going to experience something called the method overriding. Method overriding. So method overriding, know how to override or you have overload. So we usually meet this kind of terminologies, right? Yeah. So to override the method is to have different implementation from existing method. For example, an animal can walk, right? An animal can walk. Let's say an animal can speak. Yeah, speaking is just more like getting out a sound. But does a dog speak? No, but it does speak in a certain way. So that's why we can say a dog can bark, right? Yeah. So overriding is using this method of speaking and implement other features of a specific inherited child. That's a dog class. Now we can put, instead of saying an animal can speak, we know it can speak, but speak is too abstract or too general. That's why we say a dog can bark. So print back in there. By the way, we're going to see all these kind of things that we're pointing to. Anyway, from there, from there, I really look forward as well to do the practical part. One last thing before we do such, we have to understand inheritance. Types of inheritance, right? Yeah, we really need to understand these concepts, please. So, types of inheritance that we want to discover here. So the first type of inheritance is called a single inheritance. So what a single inheritance does is where a child class inherits from a parent class. A child class inherits from a parent class in just one instance. Okay? And I can maybe draw something like a symbol here. If this is a parent class, this is a child class inheritance. This is a single type of inheritance. We shift to multiple inheritance. Multiple inheritance. Multiple inheritance is where a child class inherits from two or more parent class. I hope you can imagine this. Do we actually inherit our attribute or behavior from our mother and father? Perhaps we do. Yeah. So it's a type of inheritance where a child class inherits properties and methods from more than two parent class. In short, more than one parent class. So two going up. So to draw this kind of situation is where we are saying something similar to this. This is a class inheriting its attribute. So a child, this is a parent, that is a parent. From there, should we shift to another type of inheritance is called the multi-level. Multi-level inheritance. Multi-level inheritance is where a child class inherits from another child class, and that child class inherited from the other child class, and forming like a chain. So this is a chain of classes inheriting from one after the other. So to draw this kind of situation is just by doing this, like these people. Yeah, that's kind of multi-level inheritance. See, all these are child class. Eventually, we must have a parent class from somewhere there, right? Yeah. Hope you are getting this in a bit by bit, and we must have to see this kind of implementation in practical sense. Sure. One last of all, inheritance before we start practicing. It's called the alaiko pronunciation, my people. So this alaiko inheritance is where multiple child classes inherit from parent class. Multiple child classes inherit from parent class. So multiple child classes, we do them this way, right? Yeah. Multiple child class inherit from a parent class, forming such kind of ILACO level. So this is where a child class, multiple of these, multiple of these classes inherit from parent class. So we may have another other child classes here, then they will all inherit from one parent class. I hope you should have to kind of see this kind of relationship we are drawing. Okay. Now, to be so specific, in order to model this kind of diagram, we are here. So, a parent class, then these are child class, inherited from one parent class. So, the definition is multiple child classes. So, we may have these classes that were inherited in the chain, but they all gotten the property from one parent class. I hope you can draw in your mind this kind of relationship or in real life situation. We may have vehicle A and we may have different type. Vehicle means moving. So transportation, we may have air, right? We may have land, we may have water. Another one, I don't know. So from this, air transport, we have got various kind of air transport. Yeah, we start classifying them just like that. Okay, we have spoken so much on this concept, types of inheritance, and different names of different names of parent class and the child class. We shall therefore move on to practical part. So in this session, we aim to deliver about 4 classes, and if you are not interested in the first part, you may skip the video, forward it, and you may find yourself at vehicle I like it, or at part 3 or on part 4. So the first part is requiring us to create a base animal class with attribute name, age, also the method speak. Then we shall print animal speaks, also their description. Therefore, we shall also create a subclass, you know what I mean here, dog and a cat, that overrides the method speak. You know what to override, we have described it. As you can see, dog and cat are inheriting from one parent class, and we can therefore draw this kind of relationship of inheritance, of which, should I mention it? I guess so. Okay, I've pasted the question here as a comment so that you can both track what you're talking of. Create a base class animal with attribute name and age. Let's do this so fast. Okay, with attribute, shall create a constructor name, comma, age. Okay, and in this guide, we are practicing whatever we have learned from the introduction of OOP, class method, properties, encapsulation, all those things we must be combining them. Yeah, so I'm making this attribute to be private because it's good practice to do that. Dot age is equal to age. Okay, we have done that. We can also validate, we can do different things in here, but for now we just want to demonstrate inheritance. So they want us also to create a method of speak. A method of speak. I'm going to use this property so that when calling the method, I don't have to put the parentheses there to showcase that it's a method. Self, an animal can do what? Can speak. And this was so simple, right? They even gave us the implementation detail. So we just have to print by saying animal, animal, speak. From there, we have to put a description method. Okay. So we have to describe that kind of animal. So I'll keep using this kind of application. I know we haven't been asking the question, but these are the things that should stick in our mind. It's for your own good, by the way. So speak, describe. What are we describing? The kind of animal. So this animal description, on description detail are the instance attribute, their name and shan. So description we shall just print, and therefore by saying animal details, we proceed the next line. Then we shall say name self dot name. Okay. We also proceed in the next line, and we say age of that animal is equal to self age. Okay, this is the simple thing from now. So create a subclass dog and a cat. Then we override the method speak. Okay. This is where it gets more interesting. So this is the namespace of an animal, right? This area. So anything written inside, it is called the inner class. So we don't want anything that's to do with inner class. This is separate. This is a separate class we're going to create. If we want, we can also get this class outside this file. Right? Yeah. So the name of this class will be dog. Then inheritance, the way we show inheritance, for us to demonstrate inheritance, we have to pass the name of the class inside the parentheses of the definition of the class, like that. That means I've inherited all the properties of this class. By definition, you remember that, right? Yeah. Now, look what they want us to do. So after I create a subclass, they want to override the method speak. Okay. Therefore, we shall declare that method def speak. This is called overriding because we have already inherited this method in here. So I can just print it out, but I want to make some difference, right? Yeah. So we shall say print. So this is a dog which actually barks. Speak. We are just going to we are speaking, right? Yeah. So what is left for us to do here is to say I can back. I can back. So for us to say I can back, we should maybe mention the name of this self dot name, say hoof. Yeah. So whatever name we're going to receive, if it's a dog, we say dog, say hoof, something like that. Then we go out from there, we create another method for description because create a subclass and that override the speak method appropriately. Okay, that was too basic. That's what was requested of us. So we just create another class called cat and we inherit. So these two classes are inheriting from animal class. Okay. Then we override the method of speak. Print, then we shall say a cat meow. A cat says meow, something like that. Hope we haven't made any mistake from there. So we shall create a main method in order to demonstrate the abilities of inheritance. So we're going to create a dog class is equal to dog, and we pass. So this is the where interesting part comes in. We said that for every class that is created, we have to, every class must have a constructor. But look guys, you are not even asking, please. These two classes haven't implemented the constructor, but the only constructor is coming from the parent class animal. But how come this object coming from this class called dog is going to accept the constructor? It is because it has inherited from the animal class. As we said, you inherit everything from the parent class. So we can call the constructor that way and pass the argument that were expected in animal class. And what is that? It has a name. So the name of this class is called bingo. From there, we shall pass the age of this animal. How long does the dog live? Maybe they can reach to 3 years, probably. Then from there, we also create another object from the class of a cat. So we shall say cat. Same applies, the cat has also inherited the property from its parent class, this one. That's why we haven't implemented anything there. And please tell me the name of the cat. I don't know. So we shall say kitty. That's what people say. And the cats can live up to 5 years. I don't know. From there, let's now demonstrate the method and we try to print, because the parent class only has a property of describe, of which the child classes we haven't implemented such method. So, but let's use this object to print something from the parent class. Shall we do so? Okay. So dog dot describe there. And there are special abilities where we have indicated the property. This property allows us to safely call the method without indicating either if it's a method or not. So by just saying this, we have already called that method. From there, we shall also call a method for speak. Dog dot speak, and we shall see what will come there. We will do the same thing to the cats. Cat dot describe and cat dot speak, and let's observe the output. If we don't have any errors, then we have successfully debugged and packed the classes of inheritance. So let's run this program. Okay, it's a new terminal, and we are just going to say Python. What's the name of the class? It's an animal that we're trying to compile or to learn by the interpreter.py. That's suppose if you don't have any errors. Okay, perfect. We have such details. Now let's look at the output. We created dog and the constructor from the parent class. We had put bingo and 3. And the description method, when you said describe, dog.describe, this is the description that has come. Animal details, which is named bingo age 3, right? Yeah. And the cat, which has inherited the constructor from the parent class called animal, its output, it's like this, like that. Yeah. So a cat can speak. Have we seen that part to be shown? Dog speak. No, what was it for? So whenever we call speak, it has to say a cat says meow. But we haven't, the method doesn't been called unless we do something like that, right? Then we expect some output. A cat says meow, a bingo says meow. But as we don't want to be showing that this is a method I'm printing out. So that's where we come to put a property. A property. Where is it? Speak. So here it should we should have output property. Okay. Even on the overriding method, we should have indicated property. Okay. Then we do the modality that way. Let's see. Okay, great. A kitty says meow, and what? A bingo says meow. These are the last lines which we expect. Perfect. We are now moving from the first part to the second part, which is called the vehicle hierarchy. Design a vehicle inheritance hierarchy. Base class. A base class should have a vehicle. Should have a what? A vehicle hierarchy. This is a class. Design a vehicle inheritance hierarchy, which is a base class. You know these terminologies, right? That's a parent class should do, which is named as vehicle. Should have attribute make, model year, and fuel efficiency. Then subclass, which is called the car, should have add number of doors and trunk size. Then another subclass called truck should have a truck and trailer, you know the thing. Should have payload, towing capacity. Then a subclass which is called motorcycle should have engine size, sidecar. Then they ask to say, implement a method, calculate fuel cost, distance price per liter in the base class. So these are the things that we are going to do. Okay. So let me just copy this part so that we all be following step by step. Sure. Right, we are here. We have been told to create a class called vehicle. Okay. Oh. So we create a class called vehicle. We create a class called vehicle dot py. Okay. So we then comment the code, the question there. All right. Then we shall create this class called a vehicle class, uppercase L. Okay. Now let's follow what we have been told to do. All right. Come in. Yeah, it's just outside. He's coming. No, yes, you can come in. You can have a seat there. It's just gone out. Oh, so please, okay. So from here, we now implement what you have been told to do. So we're about to design this vehicle inheritance hierarchy. So we describe the various inheritance. So one of them is an hierarchy relationship that we are about to demonstrate here. So a base class, which is a vehicle, is going to have these variables, right? Yeah. So from there, we create a constructor. Okay. We create a constructor that will receive these variables. The first one is make, second model, third year, and the last fuel efficiency. From there, then we implement these variables. And we said we are practicing good programming here. So we are making those variables to be private. Okay, we're practicing these variables to be. Then from self, we make a model attribute. Okay, then self dot year is going to receive year. From there, we make a last protected attribute encapsulated. In other words, we call it fuel efficiency, which shall be equal to fuel efficiency, something like that. Okay. What other method are we requested to do? I've been told we haven't been told so much, but look at the last statement. Implement a method to calculate fuel cost, which is distance and price per liter in the base class. This is a base class. So we shall just deliver a method that way. Okay. Def calculate fuel cost. Then we shall say self based on the distance and price per liter. Sorry for this kind of naming variable. They are too what? Too much. Okay, but I hope we are managing. So now we shall create a method liters needed in order to calculate fuel cost. Liter is equal to distance divided by fuel cost. The fuel cost is coming from fuel efficiency, right? Yeah. And I hope there are other ways of delivering or calculating this kind of operation. But for now, we are using these as my method. Shall say fuel efficiency. Then from there, we shall calculate liters needed times price per liter, this one. So instead of writing a formula, we shall just say return liter needed times price per liter. Okay, I hope we are doing well from there. Now we shall move on to a second superclass that we have been told, which is a car. And a car is not part of vehicle, so we move on and create our own class called car. Okay, and it shall inherit vehicle. From there, we have to provide the constructor so that we utilize that method we called the super function. So first of all, this one is going to obtain this that we have been told. A car shall have number of doors and trunk size, something like that. Okay, number of doors and trunk size. So number of doors, comma, trunk size. Okay, now before I move, so we are saying once we utilize a super method that actually implements a constructor from a parent class. So just like this, then you call the constructor from a parent class. That means I've called this constructor. And basically this constructor requires to pass these arguments. And we shall take them. These. And we see them from that side. After doing so, the behavior now, so when we call this constructor, it has to expect to pass also the argument of those. So this make, we are going to overwrite them there. Make, we have model, we also have year, as well as fuel efficiency. Okay. Pay close attention in what you have done. Anytime you call a constructor in the base class, you are expected to pass the parameters that a super constructor is having from there to A. Hope you get that. So that is, this car class is having its own attribute, but it's also expected to deliver this attribute because they came from the parent class, right? Yeah, we must never forget that. So you have to implement these variables as instance variables. Which variable are we trying to create here? No, we're trying to create number of those. Number of those equal to number of those, and self dot private trunk size is equal to trunk size. Okay, is equal to this variable. And we say we are practicing something beautiful here. Okay. From there, we create a method. I think that's what we wanted to demonstrate. So the overall of this session is to demonstrate hierarchy relationship of classes. So I think we are done here because that's what we were asked. We now move to track. So it's a vehicle, which is a car, it has a track, a motorcycle. Okay. So we create another class called track, and we pass the animal, we pass the vehicle, I'm sorry, vehicle class. Then this track is also expected to deliver some constructor. So we implement this self. So let's say what we are asked. It has to have payload capacity, towing capacity of this track, right? We know a track. I hope you understand these things. So payload capacity, as well as towing, how much it can pull, towing capacity. From there, since this is what is termed as inheritance abilities, so it is also expected to receive the super constructor from its parent class, and we implement what was requested. So nothing stands from there as well. So self make model. So this is a track, a vehicle, a track. So also a vehicle has to have make, model, year, and fuel. All these are gotten from the parent class, and we explained that we also have to pass the argument from the constructor of the child class. Yeah, fuel efficiency. Okay. So from there, after doing so, we are expected to create this instance variable. Already these are the instance variable that have been fulfilled from the parent class. Okay. So instance vehicle, which is payload capacity is equal to payload capacity. Then we say self, this must be a mistake, this must be dot. Okay, self dot towing capacity is equal to towing capacity from the parameter. Okay, I think we are only left with one last thing, which is called a motorcycle, right? Yeah, a motorcycle. Okay, then it's expected to pass some argument called inheritance. Then this motorcycle, a motorcycle is a vehicle. This is in relationship. Then we fulfill its constructor. So what do we want this uh, motor vehicle to have? We want it to have these variables: engine size and sidecar. Okay, that is, we are putting engine size and what side. What is this? Sidecar. Okay, I think from there we have to uh, call a super method from a parent class. Then we do the same of fulfilling the argument in there. So this argument should also go in that constructor of the child class. Model fuel efficiency. Okay, I hope you are following from A. My bad. After doing so, we create what? We create instance variable from the one we are receiving here. So we are receiving engine size. So engine size is equal to engine size. Save dot z sidecar is equal to sidecar. Okay. I think from there we have have to demonstrate the functions of these inheritance. All right. Yeah. So we are expected to call a main method, and mind you, it's not always that to be writing everything in the same file, please. So would even write the main method outside this file. Then we just say from vehicle import the classes, right? Yeah, we demonstrated that in the very beginning of the sessions. All right. So I'll more like comment testing creating object. So we'll start with my car is equal to car. This car, where is it? This one is a class and it requires all these arguments to be passed. Okay. My car, make it is Toyota. Then model Corolla. Also, yeah, it was made 2026. From there, we put yeah, it was made then fuel efficiency, that is 15% consumption. Then number of doors, a car usually have 4, and tank size, the back of that car. Is it big or what? Maybe it's large. Okay. Then we can also calculate the cost of the car, fuel cost. Why is that method? It is from there. But since the car has inherited the properties of the vehicle, so we can just call the method from my car object is equal to my car dot cost of fuel. How can we call that method? Cost fuel. And we said we are practicing good programming. So we put property. Yeah. So cost of fuel, car fuel cost, distance price per liter. My car fuel cost is equal to. So this is where the problem comes. In a normal operation without a property, we would have said distance it is 150 per hour, then liters is 1.5, right? Yeah, should have been a normal operation. Since there is a property to confuse the enemy, we just do them that way. And the program itself, it's automatically going to put distance and price per liter, and it will calculate cost of fuel. Okay. And from there, we can just, since this one, it is returning the cost of fuel, so it's a variable, it's not printing. So we may say cost is equal to return the result. It's time to print out what we have done here. So fuel, maybe more like total fuel cost, dollar, this sign is a quater, then we put cost. Right? Yeah, I think that's all. What other things have we demonstrated here? Property, fuel cost, yeah, fuel efficiency. I've used yeah model make. Okay, so it's basically we are not printing anything here, right? We are not printing anything here, and we shall therefore say that this is boring. Yeah, this is boring. At least to describe the car. So let's put a description in each and every method. Yeah, we put a description in each and every method. So the description we're going to put in a car, in a vehicle, the parent class. So there is this special type of method called str. It's a string class which is usually inherited from the developers, the one we are making Python. So it comes with the package. So it's the one done, the printed function done this format. Okay, so we shall now start displaying the basics and the details of whatever we received in there. Sure. So make vehicle details, which should come in the next line. Then we shall say make, then we say self dot make. Okay, right? Then we move on to, should also display in the next line. We move on to the model. Say self model. We move on into the next line. We say here it was created. Here, okay, created or here bought. Okay, maybe here created. Okay, here created should be self. Yeah. Okay, something like that. So we can even output fuel efficiency. Okay, it should also come the next line. Then we'll be like fuel. Yeah, fuel efficiency. Then should be like self dot fuel efficiency. Okay, fuel efficiency, then we ask that should in the next line, and we don't understand that part. Okay, let's maybe leave it this way, or will come later. Right, I intend to do this. We can back this later. So we are saying this is a super string method that will be inherited every time this side. Right? Yeah. However, this string method, we can override it in each and every method. In each and every method. So overriding, like we overload the other in a animal class. Overriding SCR method. Okay, we create def, and then this is instance variable self. Then we want to override it self. What do we want from there? So we want to append, because if we just print out, like for example, this is my car, right? We say we have calculated the fuel cost and we were about to print. Now we wanted it to print the details of a string class, which is of my car. So we should just say print my car dot string, right? Then if we print this method, what will happen? It will return information about a vehicle, year, efficiency, model, and make. But we are dealing with a car class. That means it's going to give the details like number of doors and the trunk size. So we want those number of doors and trunk size to be part of the string. Okay. So that's how we want to overwrite it or override it, right? So by overriding, first we have to invite this method there, the output of this. So by overriding it, we can get a variable parent string in short. Then we're going to say super dot call this method. Okay. So parent string. So when we call this method, it's going to be assigned to this. That's what we are seeing in there. Right? It's going to return those variables. So after it returns, we want it now to retain the overall thing in a car class. So retain these details because we want to add the trunk size and the number of doors. So we can just put it parent string, then to output there, and then we concatenate this number of doors and trunk size. Sure, right? So we can therefore say develop in the next line. So say number of doors, then we'll be like self dot number of doors, and develop in the next line. Then we shall say trunk size, which is this one, trunk size. Trunk size, to output it, we have to call the self dot trunk size, like that. So we have overwritten the string method, or we have override. So we have override it by first giving us the output of the parent class, then we append the other details like number of doors and trunk size to the returning function. So parent string is going to output together with these variables. All right, and we shall do the same to the rest of the child classes like track. Maybe we just copy this part and bring it in here to its parent class, overriding it again. So we do the same thing Then we just change what we expected in track vehicles. Where is the track vehicles? Is this one, and we expect to put the payload cap and towing cap. Therefore, shall we move this number of doors? Is not necessary, which is payload capacity. Then it has to print the payload capacity A. Payload capacity. Then from there, it also has to print towing size, not trunk size. Okay, after it prints such, then we have to return this variable, but we have to return this self method. So we delete this one, then will be like self dot return towing capacity. Okay, we are overriding the string method. We are doing the same to another last class. Okay, we have done the same there. So it's the same thing to do. We have to put engine size there and the sidecar. And the rest of the information we already have. Therefore, number of doors will be changed to engine size. And we shall format this string to put engine size and the trunk size A as sidecar. Then we are not interested in this variable. We output this sidecar. Okay, I think we have done the right thing from there. So that is, whenever I create an object I call car, we are utilizing the car method here. And we want to output this string size. It's the one that should be returned from there. And course, calculate fuel cost, we demonstrated this. Now it's time to learn this program. By learning the program, we have to call the main method. Then we learn the program. Let's test it. Right, so we have to test in order to learn this program. But before we even do that, let's just double check on what we were doing. Okay, what's this? Yeah, so we have created everything, and we just want to see the syntax about everything here. Okay, so we have made this returning string to be a property so that we call it directly without parentheses. And the other part is, when you call a super constructor, you don't need to put anything like self, because it's like you call it, all you have to do is to pass arguments in there, right? Yeah, you just have to pass arguments, so you don't need to put self there. And another emphasis is, when you call a super constructor, you don't have to call a semicolon, because you're not defining, but you're just calling a method. Yeah, those are the few things that I want to point out. Okay, now let's try to learn this program and see the output. Okay, so we just have to type Python vehicle, because that's the name of the class, and let's see the output of these. Okay, great, we have such kind of result. So my car, Toyota, and we pass argument, and we have found that total fuel cost is 6,033. This is a method that has brought this, and this string, it is bringing the formatted input of all instance variables, and you can read vehicle details. Remember this part: make, Toyota, Corolla, year created, and number of doors, also trunk size and that size. And this is none, somewhere an error, not necessarily an error, something that has brought from somewhere. Okay, all the point is, we have demonstrated how we can use these variables. We can do the same to other classes like motorcycle. We can actually do the same. So if I want to call a motorcycle class, we we just call my motor, then we call its class motorcycle, then we pass the argument, the kind of motorcycle, the make, we pass on the type of motorcycle, eligible. Okay, here it was made 2022. Efficiency, this variable after the A, it is receiving what? Fuel efficiency, maybe 3 liters, and the engine size 2, and is it large or small? This based on the motorcycle argument in there. So it's 1, 2, 3, 4, 5. Motorcycle is receiving 5 arguments. 1, 2, 3, 4, 5. Okay, that we have passed there. 1, 2, 3, 4, 5. Okay. Now let's try to print the string of this variable, and we determine the output. Okay. Print my motor dot string function, and we observe the output. Okay, we have some errors there. It requires 5 position arguments, but 6 were given. Let's try and debug this part. Okay, so let's recompile this program and we see the result. Python, name the file is vehicle.py. Okay, we have this kind of situation. Let's try to save this. Save engine size is not defined. Okay. There must be a mistake there. Test it. Okay. Think we have the result we expected from A. So my car, it has calculated the cost, then print total cost is the one that we have there. Then print my string from the car class, then it has printed the details from A. Okay. Yeah. Then for vehicles, vehicle details for the owner, based on their input, it has brought this part. All right. Okay, we have successfully covered for inheritance. In the next session, we'll be looking at some other aspects. So for the remaining part, you can answer this part because we have demonstrated the previous was talking about hierarchy. Also, this part will be focusing on hierarchy. This part will be focusing on deep inheritance, and we are hereby we'll be waiting for your feedback. So in session, we'll be looking at multiple inheritance and mixins. All right.